power functions. Power functions are any functions that can be written in this format. Y equals kx to the p. I will give you a few examples of power functions which can be written in that format. Something straightforward and simple like this is a power function. The power is 1. My constant is 2. Also, this is a power function. If I wanted to write it in the y equals kx to the p format, I could simply bring that x up by making the exponent negative. Now my power is -1 and my constant is 2. So that's also a power function. Other formats may look something like this. This is a power function because every radical can be rewritten as a power. So this is a power function. My power is 1/3. My constant is 1. Yes, ma'am.
So basically anything that has an x value, whatever you can give, it's a power function.
Anything that has a constant and an exponent is a power function. The variable cannot be an exponent. So the exponent must be a constant. Also, power functions only have one term, meaning what I'm about to write is not a power function. This is not a power function because unlike the top one, they're both lines, y equals 2x, y equals 2x plus 3. But the bottom one has two objects. A power function can only have one and only one term. There can be no addition and subtraction in a power function. Only a constant out front and a power, nothing more, nothing less. Everyone okay with that?
You say only one constant.
Only one constant, only one exponent, only one variable. So this has an extra item, means it's not a power function. Also, this is not a power function. The reason this is not a power function because my variable, my input variable x, is an exponent. On a power function, the x is never a power. It's not an exponent. The exponent must be a constant for it to be a power function. So, not a power function, not a power function. Now, we're going to break power functions into two different types. One type we will call direct proportionality, the other inversely proportional. When we talk about direct proportionality, that is when a power function has a positive exponent. So, any power function that has a positive exponent, we will say that it is directly proportional. For instance, looking at this power function, I can say that y is directly proportional to x to the 1/2? Because my exponent is positive. Also, 4 is my constant, but when we're speaking about proportionality, we call that constant the constant of proportionality. So 4 is the constant of proportionality. Sometimes when we're talking about direct proportionality, we also use the term that the y value varies directly with x to the 1/2. So 2 different ways I can say it. Y is directly proportional to x to the 1/2, or y varies directly to x to the 1/2. Now, using direct proportionality formulas, we're going to start with something like this. Oops, I'm sorry, I didn't want to start with. Oh yeah, we can do this. We're just going to use a formula to find y when x is 8. In a situation like this, we're going to use this just like any other formula. We're going to plug in our input and solve for y.
Is that a 3?
Yes, that is a cube root. So, we have y equals the cube root of 8. The cube root of 8 is 2. And 2 times 4 is 8. So, when x is 8 for this power function, y is 8. I'm also going to ask you to identify what is y proportional to and what is the constant of proportionality. So, I would answer that by saying y varies directly to either the cube root of 8, or you can write it x to the 1/3. Says the same thing. With 4 as the constant of proportionality. We're now going to look at some other situations where y is inversely proportional. Inverse proportionality can be written in one of 2 ways. It can be written with a negative exponent. For instance, y equals 3x to the negative 2. If it is written this way, I can state that y is inversely proportional to x squared. However, it's more frequently written in this format. And when we write it this way, our p becomes positive because we're flipping its side of the fraction bar. Both statements are exactly the same. 3 times x to the negative 2 is the same as 3 divided by x squared. So either way is technically a valid statement. It's just a lot more easy and direct to see that as x is getting bigger, that fraction is getting smaller and smaller and smaller. That's really the essence of inverse proportionality. When we look at the first quadrant, as x gets bigger, y is going to get smaller. So, inverse proportionality. Now, either way, we're going to call 3 our constant of proportionality, whether it's direct or inverse. Let's take a couple of examples of finding the constant of proportionality. Don't want to give it to you. Y equals k over x squared, where y is 10 when x is 2. So in this formula, this setup, we're going to find our constant of proportionality. So I've got y is inversely proportional to x squared. Let's find k. So I'm going to plug in 10 for y and 2 for k. I'm going to simplify. So I have 10 equals k over 4. To separate everything away from k, I'm going to move that division with multiplication. And I get the constant of proportionality is 40. I can now write my formula. Y equals 40 over x squared. I can either write it this way or I can write it with the negative exponent. So either way is acceptable. My preference would be to always write it as a fraction. Not always. Right now, yes. Later we can set up the whole formula. In fact, let's go ahead and move on with direct and inverse proportionality, other things we can do with it. For instance, one of the things we can do with direct and inverse proportionality is the same thing we do with any other equation, is model it. Let's say I was to give you some data. Let's look at this data over here. Let's let x equal 2, 4, 6, 8, and y equal 9, 2.25, 1, and 0.562. And I'm going to ask you to model this with the power function. So right now I don't exactly know whether I'm going to have direct or inverse proportionality. However, every time we model data, we're going to always use the same technique as every other thing I've taught you to model. We're going to start off with taking that data, take that data, push your stat button, hit, let me move it down. I'm just going to actually move this whole piece of paper down so the light's better down here. Okay, going to take my stats, I'm going to go to edit, and we're going to enter that data into the calculator. Same as we've always done with statistics. Once we enter that information,
If your last one is wrong.
no, you just can't see the 0 in front of it because it won't display it. But it,
No, you got it.
oh, I see. You are right. 0.562. Oops. Hang on. There we go. 0.562. Now, just like everything else that you model, you can start by pushing the stat button, go across the top to calculate, and we're going to choose the right setup. In this case, the right setup is not a line, not a quadratic, keep going down, not a line again, not linear, not exponential, but notice A on mine is a power regression. All we have to do is tell the calculator to run that program to do the power regression by hitting enter, and then by hitting enter one more time. Now, I'm going to write this formula down, and I'm going to also teach you a new and unique shortcut for this. So here we go. Y is approximately, I'm just going to round to the whole numbers. 36x to the negative 2. Everyone okay with that? 36x to the negative 2. Or I can rewrite that as 36 over x squared. Of course, whatever you do, please do not give me a screenshot with a equals and b equals. Now, I'm going to teach you a new technique I learned. Let me go ahead and, I need to change my setup real quick because I changed it for my calculus class. Okay, I'm going to go ahead and make that a regular line. Let's see. Quit. Let's see, what was that? Stat, calculate a x power regression, and I'm going to push variables, y variables, number 1 for function, number 1 for y1. Everyone okay with that? Watch one more time. Push, actually variables, y variables, number 1, number 1.
Wait, you said where do you put, okay.
Variables is right there.
But you have to get power regression first?
I did a power regression.
With
Then
the old information or is just?
let's try this again. Stat, calculate. We want to calculate a power regression. Hit enter. Now push the variables button. Do you see that variables button? Push it. Go over to y variables. Push number 1 for function. Push number 1 for y1. When I do that, not only does it give me the power function as I gave you before. Everyone see that? When I push y equals, it's already there. Push y equals, you'll see the formula there. And when I hit zoom stat, not only do you see the data, but you see the curve going through the data. It's a little shortcut so you don't have to enter the formula yourself later. Don't worry if you forget. I'm recording this for video for later. And that is how we do a regression from data for a power function. This one happens to be an inverse proportionality. There's one other type of skill on this that you will be held accountable for on the final exam, and that's this type of question. What happens to y if you double x, question mark. Now I'm going to give a couple of examples of problems you can do. One I'm going to set up this way. Y equals kx squared. Now notice in this situation we do not know what the constant of proportionality is. That's okay. I'm going to show you a technique, and you'll have to follow this technique exactly later to be able to answer this question. So I want to double x, but what does that mean? Well, a good place to start with x would be an x value of 1. When x is 1, I'm going to plug it into the formula. I'm going to simplify it, and y is k. Now, even though I don't know what k is, I know how to double the x value. If the x value is 1, doubling it will produce a 2. And I'm going to plug that in the formula. Now I'm going to describe what happened from the first y value to the second y value. If I double my x value, y value will be quadrupled. Or I could say, if you double the x value, the y value will be 4 times larger. Does everyone see that 4k is 4 times larger than k? Yes, ma'am.
Is it a coincidence if we do like a shortcut that you do twice the number that you were putting in and then?
Oh, I can continue this. I can keep doubling x and see if the pattern holds. So it doesn't matter what we start with x. I could have started with 2 and then doubled that x value to 4. 4 squared is, and notice it's a little bit harder to make my jump, but in fact, to go from 4k to 16k is quadrupled. It's just much easier to see it from 1k to 4k. With inverse proportionality, same question. What happens to y if you double x? Let's say you have this question. So once again, my technique will be the same. I will plug in 1 for x. Notice what happens whether it's direct or inverse proportionality. When I plug in 1 and simplify it, I get k. This is very convenient. So all I have to do is compare this k to the next y value. I'm going to double the x and see what happens. I double 1, I get 2. When I simplify this, I can either write it this way or this way. Says the same thing.
Yeah.
When I double the x value, yes, that x value is supposed to be a 2 there. Thank you. So when I double the x value from 1 to 2, and the answer is going to be the sentence. When you double the x value, the y value will be 1/4 the size. Couple ways we can say that in English. When you double the x value, the y value is cut in 4 pieces. Either way. Or you could say, when you double the x value, y is divided by 4. Everyone okay with that? Excellent. Some additional properties of power functions. We're going to look at some graphs of power functions. First thing I'm going to talk about is when my exponent is positive. Notice my constant of proportionality is of 1, so we're dealing with a very simple, straightforward graph. And I'm going to look at my power functions as 2 different types. One type we will call odd. The other type we will call even. An odd power function is when the power is an integer, either 1, 3, 5, or any other odd integer. The even power functions will be when I'm dealing with the power that is 2, 4, 6, or any other even integer. The reason why we classify our power functions as either odd or even is because odds all have some similar properties in the way that they graph. I'm going to start off by graphing some odd power functions. Where my constant of proportionality is 1. The first and most basic one will be y equals x. Notice, if all of the odds have some same characteristics and you know how to graph y equals x, then we're going to understand a lot about the rest of the odds because they're all going to share some of the same characteristics. If I look at y equals x cubed, it's going to have some similarities to y equals x. This would be an example of the graph y equals x cubed. What we notice is both of these have a positive constant of proportionality, and both of them have an odd exponent. Next one I'm going to graph is y equals x to the 5th. And what will happen is each time I'm going to get more and more bend. And now I'm going to make a statement. If I look at the end behavior of any odd power function, the direction it's going on the left and the right is always the same for all odd power functions. A line is an odd power function. If I take a look at the power functions, the odd power functions, when my constant of proportionality is negative, such as y equals negative x. We know what the graph of y equals negative x. What I'm going to tell you is that every odd power function on the left-hand side and the right-hand side is going to be going in the same direction as a straight line. So if you know the direction that the left and right-hand side are going with a straight line with a negative slope, then you know what's happening on the left-hand side and the right-hand side of all power functions with a negative constant. So, if I was to look at y equals negative x cubed, this one is the negative x cubed. And if I was to look at y equals negative x to the fifth, the left and right hand sides are going in the same direction that a straight line goes that has a negative in front of it. So all negative power functions are going down from left to right if they have a negative constant. All odd power functions are going up from right to left if they have a positive constant in front of them. Which means I can always make a quick rough graph of all odd power functions, whether the number in front is positive or negative, because I know what's going to happen with the line if the front number is positive or negative. So, if I asked you to make a rough graph, just a quick rough graph of something that looked like this. Then, here is what you would know. It is an odd power function, yes? The number in front, is it positive or negative? Positive, which means from left to right it'll behave like a line with bend. If it was a line with a positive slope from left to right, it would be going up or down? Up, but since it's a third degree, it's going to have some bend in it. I can make a quick, rough graph of this power function just because it's odd and my number in front is positive. Now, we're going to talk about even ones. Just like odd, even ones have their own special properties. The most basic even one, and realize we're starting off with a 1 in front. So the most basic even is equals x squared. And you know it opens up because my lead number is positive. Now the only difference between a squared and any other even is how much curve it has. So if I was to increase that curve by making it a fourth instead of a squared, it would look like this. And I'm going to tell you right now that every single even power function with a positive number will behave like a parabola with a positive number in front. All of them will always open up. So if I was to see a 6th degree polynomial, it's just going to open up steeper. Let me change the color. Blue. It's just going to open up faster. It's coming on the inside, but they all open up. As well, if I'm dealing with a negative, you know that a negative parabola opens. So I'm going to tell you that all negative even power functions open down. The parabola with a negative in front. A 4th degree with a negative in front. Oops, 4th degree. A 6th degree with a negative in front. Every even polynomial with a negative front is going to open down. Which means if I give you this formula here and asked you to make a quick rough graph, you would know it's going to have a basic shape of a parabola. My number in front is positive, which means it's going to open. So it's going to look something like this as a rough graph. We will continue talking about power functions.